Now we're going.
Yes, we're going. Okay. Morning, Lucy. I would show you your classmates, but someone pointed out to me not long ago that I'm not supposed to do that because you're all minors. You're probably not all minors, I don't know. So yeah, anybody, somebody in Yugoslavia could be watching you, and
Who told you that?
Isn't it true? Someone in
I guess that's
Pakistan right
it'd be
now
pretty
is
hard for them, I feel like, to find the video and watch
going to be
it.
looking and say, "Ooh, look at those young teenagers. I think I will try to get their ID and steal it."
Kill them.
And
They're a little far away.
I'll just start a whole bunch of credit cards in their
Yugoslavia
name.
doesn't exist anymore.
I know that. That's why it was a good choice. Okay. You've got 0.03 moles of helium. And there's a diagram and a PV diagram. And at state A, it's 400 kelvins. Now, part A is asking you to fill in work Q and delta U. So let's see if you did that right. What did you put, Sophia, for A to B? Work Q and delta U.
Oh, wait, work Q and delta U.
Yeah, all three.
0 plus.
Correct. Did all of you do that?
Hallelujah.
What did you put, Jaden, for B to C?
Minus plus 0.
Correct. Did all of you put that?
Nope. Oh, geez.
And then, Jack, from C to A, what did you put?
Plus, minus.
That's correct as well.
What? Oh,
Okay.
no.
It sounds like some of you didn't get all three of those correct.
No, it was confusing.
So let's look. Here it is, and here it is that way. All right, this is A, and that's B, and that's C. All right, from A to B, work is 0 because there's no work on, oh, you had to explain this. Hang on. Let's look at the explanations. Yeah, that's part B. For part B, you have to explain your response for the signs of the quantities for process A to B, just that one. So from A to B, work is 0 because there's no area under the curve. You could have put that as your reason. Other things you could have put. There's no change in volume. If you just say that, they would give you credit for why work is 0. This is why work is 0. You could have put the piston does not move. Okay. You could have written the equation, work is negative P delta V, and then point out that delta V is 0. We've already kind of said that. Or the rubric says you even could have said work equals 0 by definition in an isochoric process.
Oh my God.
Could have said that.
That's
All of that is for 1 point out of 4 in part B. By the way, in part A, each process was 1 point. If you got all 3 of them right. If you missed any of those 3, you lost that point. Okay, so back to part B. Now that was work. What about Q? Or let's do delta U next because that's the easy one, I think. Delta U is positive, and here are the things they said. What I would do is look at it and say, well, that's a higher temperature, and therefore it's an increase in delta U. But here's what they said you could write for explanations. One is a kind of a conceptual explanation where they wrote this. For a fixed number of moles, an increase in pressure, see, it goes up, at constant volume, doesn't move left or right, implies an increase in temperature. And an increased temperature implies an increase in internal energy. Okay, if you wrote all that out, then you got that point. Or you could have just said state B is on a higher isotherm than A. Here's A's isotherm. It's pointed out as an isotherm. If B's isotherm was visible, it would look like that. Well, that's a higher isotherm than this one. That's what they're saying. You could have written that as an explanation. Or you could have used the equation U is 3/2 nRT, and since temperature increases, so does delta U. You could have used the first law of thermodynamics, delta U equals Q plus W, and explained it in terms of that, where work is zero. Since work is zero, we've already established that, and Q is positive, then delta U has to be positive also. So you could have said any of those things. For that second point, delta U is positive. Now the third one is Q is positive, and you could have explained it by saying, well, if, by the way, what I would have done is I would have said, here's, according to the first law of thermodynamics, I've already established that that's positive and that's zero, so Q has to be positive as well. Here's what they say are good responses. If pressure increases and volume is constant, heat must be added to the system. No, that's true. Or if temperature increases and volume is constant, heat must be added to the system. Did I just, no, the first one was pressure, this one was temperature. Or the third one again is using, which is what I did, using the first law of thermodynamics and explaining it in terms of that. Okay. Now the fourth point, if you got those first three right, you would get the fourth one. But here's what it says. For stating the, if you missed some of those points, then if you stated correctly the first law of thermodynamics, or for correctly explaining all three variables, which means you got the first 3 points. So if you didn't get all 3 points, you needed to mention the first law of thermodynamics in one of your explanations. And if you did, then you got the fourth point. There you go. That's how that was graded. Now back to the rest of these though. If you missed any of these, from B to C, you're told that's an isotherm, so you know delta U is 0. Because there's no change in temperature. Delta U is 0. And if you know that's 0, you also know, because the arrow is pointing to the right, that work is negative. And therefore, if delta U is 0 and work is negative, Q has to be positive. Okay, so that's how I would think through B to C. For C to A, some things you know, the arrow is pointing to the left, so you know work is positive. And you also are looking at temperatures, and you should know A is a lower temperature than C. Therefore, delta U is negative. If the temperature is going down, delta U is going down. And back to this then for Q, if you know that's negative, and you know that's positive, then this Q has to be negative. You can't add 2 negatives and get a positive. Or I said that backwards, I think. But anyway, yeah, that's that. So that's the answers to those. Any questions now about A and B? Anybody? All right. Look at C. You're to calculate the volume at point C. What is your answer, Kyle, to part C?
100 meters cubed.
Anybody else get 100 cubic meters?
Did not.
100 cubic meters, if this indeed is in a cylinder with a piston, that would be, you know, like a silo of size piston cylinder with a piston, gigantic piston that's going to take a crane to make it move. So that's just too much volume. What do you have, C, for the volume at C? 0.005. Is that what you said? Cubic meters? You are correct. How many got 0.005? Several of you did. What I would just do is Boyle's law, which is PV equals PV. But if you didn't think of that, you could also have done PV over T equals PV over T, same thing. The thing is, you know P and V at point. I just lost what I was doing. I'm trying to find BC. So you know what it is at A and B. You know the pressure is up here is 5, down here it's 1, and you know the volume is 0.001 down here. So if you know both of those at point B, it's the same temperature as C, so that's what you need. You could actually calculate that temperature, but it's the same at B as it is at C, so that's why the T's really don't matter. So you know that one at B, you know the pressure at C, so solve it for volume at C. Now the other thing you could have done was Pov equals NERT, because you know the number of moles. You could figure out the temperature, and you could calculate it that way. You figure out the temperature from part B because it's the same. So that would have been more work, I think, but it would still get you the right answer. All right, moving on. How about grading? Part C was worth 3 points. You got 1 point for either using Boyle's law or one of these, or this. If you started out in the right way with any of those equations, you got 1 point. The second point was for correct substitution of the appropriate values, and the third point was for the answer. Okay. The pressures were given in atmospheres, but that's okay if you're using this version here, because the pressures, as long as the P's are the same unit, they don't have to be pascals. They just have to be the same unit. All right, that's that. Now let's go to D. D. There's not a D? Oh, there's not. There's not a D. That's right. It's done. We're done with that question. Okay, that's that. Next thing we're going to do is practice a little multiple choice. Your favorite. This, Lucy, it will be in the email that you get. This set of multiple choice questions will be attached. If you want to try them before you listen to us explain it, that might be good. This is just practice. Some of these you may have even seen before. I don't know. Doesn't matter. Let's just try them. I'm going to give you a few minutes. I'll turn off the video and let you all try to do these on your own for just a few minutes, then we'll go over. All right.
Press the pause button.
Which one is the pause
It's
button?
above the red button.
This one up here?
Yeah.
Yeah. Numbers are moving again. I did the right thing without asking you. Yeah, I can learn stuff.
I believe that.
Let's see if you got number 17 right. The absolute temperature of a sample of monatomic ideal gas is doubled. Constant volume. What effect does this have on the pressure and the density? What do you think, Sarah, on number 17?
I said C.
C as in cat. How many put C? You are all correct. The density does not change because that's mass divided by volume. None of that changed. Okay. Pov equals NERT shows you that if you double the T, it's going to double the P. I'm on number 18. Which of the following statements is not a correct assumption of the classical model? Nate?
D.
D is in dog? How many put D? You are correct. You should realize that those other three statements are part of that, but the correct answer, D, the collisions are inelastic. You know that's not true. If molecules of a gas collided inelastically, they would keep slowing down until they stopped at absolute zero. All right, number 19. A sample of an ideal gas in a tank of constant volume. The sample absorbs heat energy, so its temperature goes from 300 to 600. Most of you realize that it doubled from that, don't you? Yes, you do. If V1 is the average speed before the heat was added and V2 is after, then what's the ratio of V2 to V1? Claire?
C.
How many put C, cat? You are correct, because temperature is proportional, I'm going to use green. Temperature is proportional to kinetic energy. K is 3/2 nRT. And that's proportional to V squared, 1/2 mV squared. So temperature doubles, the V increases by the square root of 2. We are looking at number 1. A solid conducting sphere is given a positive charge Q. How is the charge Q distributed in or on the sphere? What did you say, Steve, for that one?
D.
Which one?
D.
Did you say D as in dog? How many put D? You are all correct. I think you all got that, so we're just going to move on. 2, a parallel plate capacitor is charged by connection to a battery. If the battery is disconnected, did you notice the battery is disconnected? Does that matter? Yes. And the separation between the plates is increased. What will happen to the charge on the capacitor? Kyle, what did you put?
So C.
C, Cat? How many put C? Ooh, no one raised their hand, I don't believe. Jack, what did you put?
D.
How many put D, dog? D is correct. The thing is, if you disconnect the battery, if you keep the battery connected, V can't change because it's going to still say whatever the battery is. But if you disconnect it, then V can change. And that's what's happening here. So because of C is kappa, epsilon, I hope I'm remembering this right. If you increase the distance, it decreases the capacitance. And if you decrease the capacitance, then you've just got to know how does that affect this. Q can't change because it's not connected anymore. It has nowhere to go. But V can change because it is disconnected. So it doesn't have to read the battery anymore. So that's what happened. These are inverse proportions. That's how you get that. Okay. On next page, number 15. A wire of length L, radius R, has a resistance capital R. What's the resistance of a second wire? Same material, half the length and half the radius. Jaden.
B.
How many put B as in boy?
So small.
B is correct. In this case, resistance is rho L over A. Is that correct?
Yeah.
And rho didn't change, same material. We cut the length in half. The area is pi r squared, and the r was cut in half, but that's r squared. So effectively it's 1/2 over 1/4, which is 2. So it's going to be, was that the right answer? Did we say? 2r, answer B, that's correct. All right, 26. When two identical parallel plate capacitors are connected in series, which of the following is true? Sophia?
D.
How many put D as in dog? Everybody. What if I tell you it's not D? Maybe I'm wrong because you all put it. D says it is larger than the capacitance of each. No, let's see. D says it is smaller than the capacitance of each capacitor. All right. Battery, capacitor. Are they in series?
No, yes.
Yeah, series, like that. Okay. How do you get equivalent capacitance in series?
It's the 1 over.
1 over C is 1 over C plus 1 over C. So if these were, I don't know, 2, 1/2 plus 1/2 is 1. And 1 would be 1. That is correct. My rubric says it is C,
Oh my gosh.
but no, that's wrong.
That was wrong.
Yeah. Oh, what do you know? The rubric says wrong. Well, it's just a key. I don't know who made out this key. Probably me. Yeah, I don't know. I don't remember making this key out, but at some point it was made by somebody. So the right answer is D. It's got to be smaller. Yeah, you are correct. Good job, everybody. I better make a note. Who knows, I might use this little set of multiple choice again someday. Then we're on number 5. As a rock sinks deeper and deeper into water of constant density, what happens to the buoyant force on it, Sarah?
B.
How many put B as in boy? You are correct, because buoyant force has nothing to do with depth or pressure or things like that that might be changing. It's just rho VG for the displaced water. Number 25, a gas with a fixed number of molecules does 32 joules of work on its surroundings, and 16 joules of heat are transferred from the gas to the surroundings. What happens to the internal energy, Nate? Which one?
C.
Nate says C. How many put C as in cat? Kyle, what do you have?
Said A.
How many put A as in apple? A is correct. In this case, first law of thermodynamics, delta U is Q plus W. You got to read the equation and know that Q is negative 16 because it said heat transferred from the gas. It goes out of the gas. Work is also negative 32 because the work is done on its surroundings. So the gas loses energy doing work on its surroundings. So negative 48. So the right answer is A. It decreases by 48 joules. Number 7, the last one, an ion with charge Q, mass M, speed V, enters a magnetic field B and is deflected into a path with radius capital R. If a second ion has speed 2V, while M, Q, and B are unchanged, what will happen to the radius? I don't know where we are now. Who did the last one? It was Kyle. Steve. No, we're over to Jack. Is that right? Or wait, Steve? I don't know. I've lost track. Steve, what did you put? How many think it's B as in boy? You are correct. Easy way to get that is if you remember the equation, the radius is MV over QB. Okay. Any questions about those? Those were easy, weren't they? So if they're like that, tomorrow you'll all make a good grade, won't you?
Will they be like that?
Well,
They might. All right.
The exact answers.
One more thing we have today, and that's if you go back to your little packet of free response questions, there's one that we still haven't done. We might as well do it. It's the last one, I think. It's the one that looks like this.
Surface of Earth.
Yeah.
Yes.
You've got north end of the page.
Into the page.
So south is coming
What's
out of the
north?
page. All right. Up is actually up, away from the surface of the Earth. Okay.
This is wild.
Now, a proton of mass MP, that's the mass of the proton, charge E, that's the Q, it's E, is in a box that contains an electric field, E. It tells you there's an electric field E. You don't really see an E in the picture, but there is. And the box is located in Earth's magnetic field B. Okay, so Earth's magnetic field, see, is moving north, so that's what the X's are. The proton moves with an initial velocity vertically upward from the surface of Earth. Assume gravity is negligible. All right, look at A and answer that on your own. Go. You might still be writing your explanation. Some of you are. That's fine. Keep writing.
No.
But let's see if you drew the arrow the right
No,
direction.
no.
Oh, you're changing your arrow, Sophia.
Yes.
Sometimes you change your arrow. All right, since Sophia just changed her arrow, let's ask her which way the arrow should be pointing. This is for the electric field E. All right, go.
I said it was going left or right.
You have it going this way,
So it's
to the
horizontal.
right. What?
I just know it's horizontal.
Oh, you said left or right.
Yeah, that's what I said.
Oh, but yeah, that's horizontal.
Yeah.
Okay, I thought you were saying, no, it's horizontal.
No, I'm just saying I'm very unsure because I can't remember if electric fields go from positive to negative or negative to positive. I realize that.
That's correct. Did you all draw your arrows to the right? Okay. Now, why is that? Okay, let's start with B. What effect does the magnetic field have on the proton? It's going to make it move which way? To the left. And that's the right-hand rule. Fingers are in, thumb is up. Magnetic force is to the left. So that would make it veer to the left. So you need an electric field that's going to counter that by moving to the right. And this is a proton, isn't it? Positive. If it was an electron, we've had questions like that, then E and F are opposite. But you want the force to be to the right, and since it's a proton, then E is the same direction for a positive particle, E and F. You want the force to be to the right. And again, if the particle is positive, then the force and the E are the same direction. Okay, you needed to explain all that. The rubrics actually says, for demonstrating an understanding of the physics involved in balancing the magnetic force and the electric force. The forces had to be present in your explanation. You had to mention the word force, because that's what has to balance. The left force has to equal the right force if it's going to move up undeflected. It's not that E has to equal B, it's that the forces have to be equal. Okay. If you explain that, then you got the points for that. On part B, determine the speed, V, of the proton. Go ahead and calculate what V would be. Express your answer in terms of the fields and given quantities. All right, go. All right, then tell me, who's got an answer? Jaden does. What's your answer?
V equals E over B.
E over B. Did you get that?
Whoa, that's wild. No, I
Look,
didn't have that at all.
magnetic force equals the electric force, which is what we just talked about. Magnetic force is QVB. Electric force is EQ. Velocity E over B. Now, you should have actually written it this way, E over B Earth, because it said given quantities or the fields, and they called this field B Earth. Did they ever call it B Earth? Well, they just called it a B. All right, so I guess B is okay. The rubric says B Earth, but yeah, then up in the opening paragraph, it just says the Earth's magnetic field B. So if you just wrote it that way, you still get all the points. E over B is the right answer. Now, the rubrics also points out, I don't know if any of you noticed, V is a given quantity. And it said express your answer in terms of the fields and given quantities. So what they found when they gave this exam, I guess in 2002, some people just wrote V.
I would do that.
And they had to give them credit for that. So they put that in the rubric. Okay, we gave you credit if you just wrote V. Because it doesn't change. The point is it doesn't change, see? If it's V here, it's still V the entire time.
Forces counteract each other.
Okay. All right, so that was B. That was part B.
It's gonna.
The proton now, the proton, are we on? Yes, we are. The proton now exits the box through the opening at the top.
Now it gets wild.
C, on the figure on the previous page, sketch the path of the proton after it leaves the box.
Oh my gosh.
It's going to move straight up and exit right there, going that way. All right, so what path would it have? Sketch the path, it says. It doesn't ask you to draw a vector. It says sketch the path.
Sketch the path. I did it.
Okay, has everybody sketched the path? Is it curved? Which way?
Circle. Left.
You should have drawn a curve like that. As long as it's curved to the left, the rubric says for sketching a path that moves to the west, that is the left, you got 1 point. And the second point for having a path start out concave downward, either west or east, as soon as the proton leaves the box, and continuing that way for a short distance. So it had to look like it was curving immediately. That's the point of that. If you drew it up like this, and then up here it curves, well, you lost a point, because why would it go straight? It's going to curve as soon as it hits the magnetic field. And there's no E anymore. So it had to be curving from the beginning. That's 2 points. All right, part D, determine the magnitude of the acceleration of the proton just after it leaves the box in terms of the given quantities and fundamental constants. All right. A, acceleration. There is more than one way to do this, but you should end up with the same answer, I think, no matter how you do it. You have an answer, Kyle?
A equals EVB over MP.
Anybody else put EVB over MP?
Yeah.
That's correct. You can get that from F equals MA, and F is QVB, and solve it for A. What kind of acceleration is it? Is the thing speeding up?
No,
So what is it?
circular,
It's centripetal acceleration, isn't it?
it is.
So you could have even said this, V squared over R, and plugged in what you know for that. You'd still ended up with the same answer, though, that Kyle just said. Yeah, either way. All right. Any questions about that? You all are getting pretty good at this. We have about 3 minutes left. Who has a question about your exam tomorrow at 8 o'clock? Yes.
We learned about centripetal forces last year, right?
Right. That was physics 1.
Man, that's wild. Time flies.
Yeah. Your exam will be about 20 multiple choice questions. And then 3 free response questions. You'll have 90 minutes. So you don't want to spend more than 45 minutes on each part. They really should be about evenly timed. All right. Make sure you have a calculator that works, a pencil, your fine mind. Get plenty of sleep tonight. That's it. All right. I'm turning this off. Thanks, Lucy, for joining us. Okay, bye.